So on behalf of Department of Electrical Engineering, I welcome to Kavre sir as well as all the students. Uh, I will just give the brief introduction of Kavre sir. So sir is actually additional executive engineer at SLDC MSCTCL Mumbai. And sir is having almost 17 years of rich industrial experience in HVDC, EHVAC distribution, SCADA, WMS, renewable energy management, and grid operation. So actually, I have the profile from Kavre sir, and it's really very huge and inspiring profile. But those who have attended actually the PLC SCADA guest lecture, so sir is having expertising in PLC and SCADA also. So today actually sir is delivering the guest lecture for HV, okay, and you know that this is actually the fifth module in HV syllabus. So that portion will be covered by sir. Okay, so I request Kavre sir to proceed further. Sir.
Uh, Thank you so much, madam, for this introduction. Just I will present my slides. Madam, this screen is visible to you?
Yes, sir.
So very good afternoon to all of you. So we'll start our today's session. So that is on high voltage. Uh, that is HV testing of electrical apparatus. So I'm going to cover here all the aspects regarding standards as Indian standards or IEC standards, that is worldwide standards. So this is part sometimes it may feel difficult to us to understand IS and IEC, these some of the standards, because somewhere we are not much more interested in such topics. But really, this is most important topic when we think for the, especially for the testing point of view. So really, these standards are most important, and we'll take a brief overview of this IS and all these things. So the content of the presentation are, so today we will cover this introduction to HV system. There are various standards for high voltage testing of electrical apparatus, related IS and IECs. So those standards we are going to cover. Rather than going inside the full content of the IS or IEC, I have just quoted what are those standards and what are specially related with the high voltage system. So we are going to discuss that thing only, because whenever you go through the any IS or IEC, so it may feel some means boring, frankly speaking, because there are so many steps and so many discussions and many things are given in that. But really it is a means how actually standardization is done. Really we can means learn a lot more from this. Then in the second portion I will cover testing of insulators, bushings, isolators, circuit breaker, cables, transformers, lighting arresters, and power capacitors. So what are those tests which are carried out in high voltage lab? So that I am going to cover. First of all, we will see about the classification of voltage levels. We know that there is much more confusion in Means across globe actually there is a confusion in classification of voltage levels. Every country has their own defined rules, or we can say standards. So they are defining voltage level at different levels. But means country to country, even within one country itself, there are two standards. So there is a much more, we can say, not a such clear direction across the world. So we will think or we will discuss about what are those especially related to classification of those voltage levels. So high voltage comes under which category, that also we will see. So I have tried to see the all the means what are their standards. I have tried to cover and came to one conclusion that high voltage, where we should put that high voltage in especially a particular level. So we know that if you see Indian Electricity Rule 1956, especially Rule 2AV. So there are the voltage limits were specified in that rules. So according to I rules 1956, the low voltage, so not exceeding 250 volt, so that comes under low voltage. Medium voltage not exceeding 650 volt, so that comes under medium voltage. High voltage not exceeding 33 kV, so that comes under the high voltage. And then extra high voltages which are more than, we can say, 33 kV, those comes up to 400 kV, we can say that it comes in the extra high voltage. And more than 400 kV, we can say that it comes under the ultra high voltage. So like that we can say that. Again, there are certain regulations like now again this 1956 rules gets modified, because time to time these all the regulations time to time get update from the standardization authority or bureau of standardization, especially if you are talking with India. So BIS is there, who will standardize all the rules. So in 2010, whenever there was a regulation of Central Electricity Authorities, regulation of measures relating to safety and electric supply in 2010. So whatever assumptions we have in the 1956, so that we have actually modified. And so again, there is no clear cut idea still which is to be taken, LV, MV, HV or EHV, like this. But almost from this discussion we will come to one point, so that we can conclude that which level we can go. Whenever we are talking about NEC, that is National Electricity Code, in 2011, again it is revised and reaffirmed in 2011. So part 1 section 2 of that, it again gives some direction regarding the classification of voltage levels. Especially low voltage, they are saying that voltage which does not normally exceed 250 volt comes under low voltage, which is exceed 250 volt but not more than 650 volt. So again that comes into the medium voltage. From 650, above 650 volt and below 33 kV, so that comes under high voltage. And extra high voltage, they are seeing more than 33 kV, like this. So these are, again we will see what are the international acceptance, or what is the criteria of this classification of voltages at international level. Now if you talk about IS or IEC 60071-1, and regarding insulation coordination, so under which it is mentioned that the voltage which is less than 1 kV should be taken into as a low voltage. The voltage in between 1 kV to 245 kV, it should come under high voltage, and more than 245 kV, it should come under high voltage. Again, in IEC 60909, whenever they talk about short circuit currents in the three-phase AC system, again they have defined these voltage levels. Like low voltage, they are treating from 100 volt to 1000 volts. Then medium voltage, again it comes beyond 1 kV to 35 kilovolt, and high voltage beyond this 35 kV to 230 kV volt. So like this, these are such we can say standards across the globe. Again, in if we talk about the ANSI, that is American National Standard of Electric Power Supply Systems and Equipments. So the especially in 1989, so they are saying that low voltage is from 120 volt to 600 volt. Medium voltage comes in the range of 2.4 kV to 69 kV. High voltage comes in the range of 115 kV to 230 kV, like this. Again, as per ANSI C 92.2-1987 or IEEE ANSI 1987, again they have defined extra high voltage and ultra high voltage levels. Extra high voltage level, they are saying that it is in the range of 345 kV to 765 kV. And ultra high voltage, they are saying it is more than 1100 kV and above. So these are also some of the classifications based on ANSI IEEE. Again, IEEE 141 1993 says that, and low voltage that comes in the range of 120 volt to 600 volt, medium voltage in the range of 2.54 kV to 34.5 kV, high voltage 46 kV to 230 kV, and extra high voltage comes in the range of 345 kV to 1100 kV, like this. Again, IEEE 1623-2020, it says that medium voltage comes in the range of 1 kV to 35 kV, like this. Again, if you see the French standards, like France, so their regulation in 1998 standards, they are saying that below, that is low voltage is less than 1 kV, high voltage is higher than 1 kV, but less than or equal to 50 kV, and high voltage B, the another case, so that is more than 50 kV, like this. Again, European Electrotechnical Standardization Committee, CENELEC, in 1992, again they have defined these voltage levels like this. Low voltage, that is less than 1 kV. Medium voltage is higher than 1 kV, but less than or higher equal to 35 kV. And high voltage is more than 35 kV, like this. Again, there are standards of IEC 62271-1 and IEC 60038 standards. So these are also some of the standards to define this classification of voltage levels. But if you see, especially still there is no clear cut across the globe. There is no uniformity in these standards. But as much as I have tried to select among these all discussion, I have tried to choose the best so that we can go with these standards. So if you see extra low voltage, which means that up to 50 volt, it can be whether it is AC or DC, so that you can take it as a extra low voltage, which is less than 50 volt. Then low voltage, it is in the range of 50 kV to, means more than 50 volt to 1000 volt, AC or DC. So it is treated as low voltage. Then medium voltage above 1000 volt and up to 6.6 kV, means up to 6.6 kV we can consider this is a medium voltage. Then high voltage. About what? About high voltage, we can say that above 66 6.6 kV or 660 volt, so we can up to 33 kV, we can treat this is as a high voltage, means up to 33 kV, that we can consider it is as a high voltage. Or we can say specially 6.6 kV to, especially we cannot take 33 kV also, because people now has started 33 kV connection with the EHV. They are treating it is in the EHV band. So we can take the voltages which are less than 33 kV, that we will take into the high voltage. Then extra high voltage above 33 kV up to 400 kV. So that we will take into the extra high voltage. And then ultra high voltage. So ultra high voltage is more than 400 kV up to 765 kV, and even that 1100 kV, that also we can take into the ultra high voltage. So these are the standards we have tried to fix it as per the availability of the data. Now we will take the idea about a 22 kV substation, which we can treat it as a high voltage substation. In high voltage substation, if you see, there are especially it's a generally if we see the clearances are less, as it is a less voltage level, so clearances are less, but still all equipments are there. Like if you see here, the person is working on the CT. It is a CT actually, and these are the isolators. These are center back isolators, which open from the center. And this is a circuit breaker, which is we can say at 22 kV level. This is a circuit breaker. Generally, vacuum circuit breakers are used at this, especially low that HV high voltage side. So vacuum circuit breaker, not they are going for this, especially we can say SF6. But nowadays, especially are preferring even at 22 kV substation also, people are going for the SF6 because of their many advantages. Also, we have these CTs, isolators, and other connections are there. So, and these are actually PTs. These are mounted structures here. These are PTs, potential transformer to measure voltage. These are CTs to measure the current. So these are the equipments we which install in 22 kV substation. But before installation, there should be testing of these equipment at the factory level. And especially today's session is all about testing of these high voltage equipments. How people test these equipments, and what are the standards which we adopt to test these equipments. Why testing is important? Because whenever you put any device or any equipment in the substation in service, so there should be the means insurity of that equipment should run in good condition with uninterrupted services. So for that, you should have to test this equipment at factory itself. So there are two types of test. One is generally we called it as a FAT, that is a factory acceptance test. So actually, whenever they manufacture as per the design any equipment in the factory, then whatever vendor, see, they are not manufacturing, just go on manufacturing. What they are doing, they are taking contract from the any utility. When contract get fixed, then they start actually as per the specification required for the customer, they accordingly design those equipments, and then the manufacturing process start. So during manufacturing, all the whatever standards that are for the manufacturing, that they adopt, but still they have to test those equipments. For that, to test those equipment, and but in front of the customer itself, because customer satisfaction is most important. So they called you at their factory, and then there is a test that is called as factory acceptance test. So during factory acceptance test, that customer representative will be there, then manufacturing, that all the testing, their representatives are there. And in front of them, they carried out the testing of the equipment. And they put and they note down the results, whatever they got from those tests. So in this way, we have to follow the whatever those criterias are there before installation any equipment. We have to actually test it for its ensured operation. Later on, there is a first there is a factory acceptance test. Then for the certain equipment, there is a SAT, that is a site acceptance test. So that again at site, whenever you fix that equipment, you by your measuring methods, you test as per your whatever standards, you test that equipment at your substation or at your industry. And again, even for certain contracts, even that company representative may come to the site during your testing also. That is a site acceptance test. When again that equipment get tested on site, because we know that whenever there is a during transportation, many things happen with your equipment, because of we know that transportation we generally do on the trailers and all those things. There may be damage happen, and such incidences happen actually practically. Whenever some transformers especially they transported, and when it came on the site, actually they found there is a breakdown and means mechanical breakdown of the inside the transformer itself. So these things can happen. So for that, there is a site acceptance test. So for that, the company representative and the owner, that is a that whatever party that contract has given, so they jointly test that equipment, and then they will ensure that this equipment is now ready for operation. And then they took that in service. Again, they monitor for the certain days continuous, they keep the record of that equipment. And in this way, actually we take that equipment into service. So testing is most important aspect whenever you install any equipment in any utility. Especially if you talk about the substations, so transformer is a very critical equipment. Especially care is too much taken for the especially for transformers and circuit breakers, because they are costly also. So the testings are most important. Then if you see the power supply system, actually when it comes for the high voltage, especially it comes from the generation. If you see the generation, from that generation, that low voltages 11 12 kV like that, those voltages we step up at 132 220 or 400 kV levels. Again, that we there may be the chances that you can supply here directly to the consumers. So these are the very large consumers. So there might be on your 132 kV or 220 kV level also. So these are our consumers, very large consumers. And even you can connect with the other grids also. Another, you have again sub transmission system where you step down these voltages to the 66. Again, there is a primary distribution level at 33 kV or 11 kV or 22 kV like this. And again, you step down that with the help of distribution transformers. You divide again, it convert into 440 volt, and then supply to the 440 or 230 volt single phase supply to the consumer. So such hierarchy is there from when we start from the generation to distribution side or a consumer level. So whenever we talk about high voltage substation, the arrangement is like this. So there may be single bus. Generally, single bus arrangement is there because uh, that is not much more as compared to the EHV substation. These are not much more important substations. So generally, one bus, single bus system can be adopted. So these are the, we can say, sometimes even if it is more important substation, then double bus system can also adopt in high voltage also. Then we have these isolators, again this another isolator, and there is a transformer. Then there's 22 kV get converted into at especially distribution level, distribution voltage. So similarly, another also such arrangement can be possible. Another example, if you have a high voltage 11 kV incomer line, then you have isolator. This is a lightning arrestor because lightning arrestor is important at the starting of line to protect it from the lightning damages. Then you might have direct transmission line, or you can use cable also, underground cable. So that can also used. Then you have in the, if we talk about the transformer, so in the primary also you have CT, and in secondary also you have CT to measure the HV and LV side currents. And also if it is a suppose common bus system, so PTs are provided to the common bus. And then you have here distribution feeders. So these are the your distribution feeders which are going at different maybe at different levels. So these are our supply, that is the LT switches are used here. Here it might be happen that to avoid the for the power factor improvement or reactive power compensation, you may have capacitor banks also. So these, so every equipment whatever you have connected from this starting to up to the supply end, so you have it should be tested properly. Then and then you can ensure its operation. So all these equipments we are going to cover how these get tested and all those things. And metering is most important for this because our control and protection is generally actually with the help of this metering system, that is especially measuring equipments we use for the metering as well as for the protection. And even nowadays, even these substations, high voltage substation, we are making remote substations. There is no manpower deputed, we not depute manpower there. We make it automized substation. So generally that's why we want these signals, so that we can, there will be the central control room, and from that central control room you can observe all the parameters of that station. You can operate any breaker, isolator and any switch from a remote itself. So that's why, so these equipments are most important for this. Then what, while talking about standards, so generally if you see at international level, so there is an International Electrotechnical Commission, that is known as IEC. But whenever IECs are there, and when every country has to adopt as per their means scenario in that country, because everywhere it might happen, frequency may change, load pattern and everything gets changed country to country. So as per the, means every standard cannot be suitable for the other country. So for that we have, every country has to design their own standards. So this International Electrotechnical Commission has designed some international standards. But for here in India, previously it was known as ISI, and now it is a BIS, Bureau of Indian Standards. So we have designed our standard as per our requirement. As like our constitution, as when our constitution was made, so there were dismissed many constitution of other countries were actually studied, and later on best of that is designed for our nation. So in the same way, what is actually suitable in our means our this scenario or that power industry especially. So as per that you have to design, you have to made our standards. So this is a in IEC specially which look after for the international electrotechnical standards. So it is in Switzerland, it's in Geneva, and it was founded in United Kingdom, that is London, and headquartered at Switzerland. So this is all about this IEC. So just we can say summarize it. It can say that for the international standardization, so this IEC was formed. Then there is actually standardization management board. How this standardization actually come into picture? There are so many committees are actually working on this. There are many experts from industries as well as from institutions work on the finalization of this standardization, because it's the most important thing to decide for any industry to have a standardization. So for that there are some management boards, committees are there. So they decide, and time to time these committee members change as per time, and whenever some new methods, new standardization come into market, they are again going to revise those standards as per the present situation, or whatever industry requirements are there. As per that they revise this standard, but with the committee only or management board. So this is there is again a standardization management board of this IEC. Again in India, if you see, it's a Bureau of Indian Standard, BIS. So the history of this is BIS. It was formed in 1986, and headquarter is at Delhi. So it comes under Ministry of Consumer Affairs, Food and Public Distribution. And especially we can say that it was previously Indian Standard Institution, ISI, when it was actually formed in 1946, but in 1986 that gets gets named, it's a BIS, that is Bureau of Indian Standards. So all these it means there are so many committees, and there are headquarters. Its headquarters is at Delhi, and other regional committees are also there, which work at different regions in India. So in this way, we can say that it is the important work which actually BIS is playing whenever there is a standardization of the any equipments, or we can say especially industry. So we have two parts of this core presentation. That is a part A, which is a various standards for high voltage testing of electrical apparatus. That we have selected some IS and IEC standards for this. Then we have part B, where we discuss about testing of all the high voltage equipments. So part A will cover here all the standards, that is IS and IEC standards. So these are some of the Indian standards we have adopted. Actually, these are IECs that actually we have modified. Means as per our requirement, we have standardized these things. So now they are known as Indian Standard IS. If you see here, in 2005, we have formed IS 1876, which is a voltage measurement by means of standard air gap. Actually, it is a IEC 60052, but as per our requirement, we have standardized this as a IS 1876. In IS 1876, you will have a clear direction about voltage measurement by means of standard air gap. So these are some of the different IS which are with the different topics. So these are the specially now for the today's discussion we will have only few of these are important for our discussion. So especially I marked it here for the today's discussion. We have these standards which are useful for us, like for the high voltage test techniques part one, where definitions and test requirements are given. So that is a IS 2071-1, which was actually IEC PUP 60060-1, but that we have modified as a IS 2071-1. So there comes again in 1993 that was the part one. Then 1974 that was a part two test procedure are given here. High voltage test procedures. Again IS 2071-3 where we talk of here there is information about methods of high voltage testing, means which are the methods of high voltage testing. So that methods are given here regarding measuring devices. Then we have another standards that is IS or IEC 60060-2. It talk about high voltage test techniques part 2, that is measuring systems. Then we have IEC or IS 6001-3, which is talk about high voltage test techniques part 3, in which definition and requirements of on-site testing. Especially it is talking about the on-site techniques. Otherwise, all other are actually test procedures, or we can say factory tests are there. But especially this IS or IEC 60060-3, it talk about the on-site techniques or procedure of the this testing of the HV equipments. Again, we have another standards. So these are also, that is a high voltage, just a minute, it's a another IEC or IS 60207, that is high voltage test techniques, that is especially partial discharge measurements are covered in this IS. So these are the IS which are important for our today's discussion. Now these are the some of the screenshot I took from these IS or standards. If you want to actually, these are available on Google also. So if you search with that IS number, you will get it. Uh, Also, I have those IS. If you want these IS, I can share. So these are the some IS, that is the IS 2071 Part 2, 1974. It is reaffirmed. First, it was reaffirmed in 2001. Again, it is reaffirmed in 2006. Now, again, certain procedures they have modified into this. Some addition deletion is there. So these are the some of the standards which talk about the test procedures of the high voltage equipments. Then we have IS 2071 Part 3, which actually it came in 1976, but it is again revised in 2006. So it talk about the measuring devices, methods of high voltage testing. Again, we have these are the some of the IS or IEC 60270-2000. So these are the some Indian standards. So that we use for the high voltage test techniques, that is a partial discharge measurement. Again, we have Indian standards high voltage test techniques, that is part 2, measuring systems. So that is IEC or IS 60060-2 2010. So this is also upgraded in 2010. Then international standard IEC, that is 60060-3. It talk about the high voltage test techniques, definition and requirements of on-site testing. Now in the part B, there is a scope for the testing of the equipments like insulators, bushings, isolators, circuit breakers, cables, transformers, lightning arresters, and power capacitors. Means whatever we required at the HV level, all these equipments we have to test as per the IS or IEC standards. So these are the high voltage testing laboratories where you can test your equipments, you can generate high voltages, and you can test the equipments for their performance. So generally such setup is made where it is generally Faraday's cage is installed generally there to avoid the induction effect in the vicinity, people which are coming in the vicinity, that can avoid. So such Faraday's cage arrangement is provided here. Also, we have different types of test equipments which are used. Means you have such to test the performance of any equipment. We have to design actually such arrangement so that you put your equipment and you can test actually like your if it is like in the system or in operation. So all these now there is a means automated facility and there is a much more automation here in the high voltage testing laboratory also. If you see in India, especially if you talk about VJTI, there is a good lab for the high voltage testing. So they do even for the customers also, they do high voltage testing of the equipments at VJTI. Means there is a really good facility available. So such equipments we can test uh, before installation for any utility. We will have to test these equipments in the laboratory. So generally, many manufacturers means almost all manufacturers have their own high voltage testing laboratories because that is most important. Whenever you manufacture, you have to test on site means and the in the manufacturing industry itself. So they were having their such measuring laboratories there testing for the testing purpose. Now testing of the transformers. If you see here it is a distribution transformer shown. It is a three phase R, Y, and B. These are the three phases. It is a oil cooled transformer, means oil filled transformer. Here radiators are provided. Oil is circulated through the radiators. Then we have this is a our conservator tank where a particular oil level is maintained. This is a MOG, that is a magnetic oil gauge, which will show you how much is the oil is there inside the tank. So these bushings which are connected with the transformers, their lower lead is actually connected to the winding inside the transformer. So whatever parts actually you are going to connect with the transformer, that you should test. Every equipment you have to test. Though it is a measuring device, suppose there is a OTI, WTI, that is oil testing indicator or winding temperature indicator or oil temperature indicator. So that also you have to calibrate and you have to test whether actual results you are getting or not. Also, emoji also you have to caliber. Means all the auxiliary accessories you have, whatever you are using, that you have to actually test or calibrate at factory level itself. Then there is a Bacall's relay, that also given, so that also they need to check it's a guaranteed operation during such means there is a critical condition for the transformers. And generally this is a and there is a for the distribution transformer there is no oil force cooling, there is no pump provided, just through the natural circulation oil goes through here and it gets cooled. So in factory we have to test this transformer so that the means whatever you have connected bushing leads, so that bushing should also get tested. If your transformer is healthy but the connecting where you are making the connection with your system. So if it is weak, then also your transformer can fail. So for this, every equipment should be tested. And here, winding material, it may be aluminum or copper. So generally, whenever we talk about the cost, then aluminum preferred. Otherwise, for the EHU application, you always go for the copper windings. It is a 11 kV by 433 volt. This is the distribution transformer. Now, what are the testings that is carried out for these specially transformers? So, if you see in the high voltage testing laboratory, there is an arrangement to apply the voltages. There are variety of ranges voltage. They vary the voltages as per the test requirement. So the first test that is carried out for the transformer, it is an induced voltage test. So in the induced voltage test, they apply the voltage from the secondary side. Suppose the voltage AC source with a 100 to 400 hertz. So that frequency range voltage is given, that is about the twice of the rated voltage, means whatever rating is there, so twice of that is applied from the secondary. And whenever you apply from the secondary, that will definitely produce some voltage in the primary. So in this way, you will get induced voltage in the primary whenever you apply voltage in the secondary. In this way, you then that voltages will get measured, and then there is all their formulas and standardization. As per that standardization, those limits which are decided, within that limit, you should get that voltage. So such type of a voltage test is carried out. That is an induced over voltage test. Because sometime it may happen that suppose your HV side breaker is off in substation. If you look, suppose your HV breaker has problem, but still we keep our transformer charge condition, because to maintain it in healthy condition, your transformer should be kept in charge condition. That is known as humming condition. Means just you apply voltages from the LV side, that is low voltage side, you apply the voltage from LV side, and your transformer will remain energized condition. But to guarantee such application at the site, you should have to confirm at the site, that is in the factory itself, that whenever you apply certain voltage, what should be the over voltage that will produce in the primary site, that we have to confirm. Because at this site it may happen like this also. Then another test is a partial discharge test. So here we know that whenever suppose there is a high voltage stroke is there, whenever there is any lightning stroke on any transformer bushing or any, we can say particular specially bushing insulators. So we know that somehow some stroke that experienced by that equipment, means that discharge current, certain amount of that it passes through that. So to confirm that, so to assess the discharge magnitude, so how much it can take, means how much quantity it can take, so that according to that partial discharge tests are taken. And also to verify the radio interference levels. Whenever radio interference means whenever any nearby equipment is operating, so it may create some noise signals induced on the other. So that interference may happen. That we can call that it is a, maybe it's an induction effect actually to the neighboring equipment. So that interference, how much value of that, so that also decided by this test. Then we will have impulse testing of the transformer. What is meant by impulse? Actually, we know that our lightning is an example of base impulse, because impulse means what? Impulse means whatever quantity that actually applying on that equipment, it should be at zero moment, t is equal to zero, then that actually quantity is known as impulse quantity. It may be current or voltage. So whenever lightning comes, it is actually instantaneous, means t is equal to zero, it comes like a impulse. So in such thing, how the insulation will take care of these such things? Whenever there is a lightning stroke coming on your equipment in the fact this substation or any industry, so how your equipment will withstand with that impulse voltage? So that we have to actually test. So for that, how much means they apply variety of voltages, and that should they apply at t is equal to zero, means all of a sudden instantaneous how that equipment will behave, that they will check there. There may be the possibility of whenever you apply impulse to any equipment, there are chances, because it's a all of a sudden impulse which may break the insulation if it is not properly designed. If there is some manufacturing minute defect also, that can be actually verified with this test. But there are different procedures adopted here, how much quantity we should apply for this test. So there are certain criteria for impulse testing. Whenever you apply impulse voltage, so this is the first test that they apply voltage magnitude of 75% of the basic insulation level. So whatever basic insulation level of that equipment is there, suppose is it designed for the 420 kV. Suppose you are connecting that equipment in 400 kV level, and its basic insulation level is 420 kV, and you are applying 70% of that, means you are checking, oh okay, if that test pass, it has sustained that equipment 75% of voltage, it's okay. Again, next, they choose like this one full wave voltage of 100% BIL, means 100% of BIL means 420 kV. They will apply it with one full wave voltage, one full wave voltage. Second, they will apply two chopped waves, means not complete wave, but they chop the portion of that wave. Suppose complete wave will not come and just there is a chopping, means half of that, suppose, or some part of that wave, if strike on that equipment up to its 100% BIL, then what will happen? Then one full wave voltage with 100% BIL, and one full wave with the 70%, 75% basic insulation level. So in this way, they with the different voltage magnitudes, they carried out this impulse test, so that insulation level we can ensure that it can stand to any extent for any impulse. Again, there is a testing in the testing of transformers. There is a detection and location of fault during impulse testing. Suppose there is some manufacturing defect, so that may also can be identified, because it may happen sometimes. It is not. It may happen sometimes, not always. Minute, some difference may remain. So I am remembering one thing, that how manufacturing defects, especially we experience in HVDC. So actually that there was one defect, especially for the converter transformers. Whatever transform we took into service, that after certain days they were going to fail. Means they were failed actually on the site itself during their normal operation. So manufacturing defect, especially we can say that that was not with the design aspect, but especially that was with the selection of oil, the coolant which they have used. That was actually means that oil itself was reacting with the copper of those windings, and actually that started means some deposition, copper deposition inside that, and during normal voltages itself some arcs develop inside the winding itself, and in normal operation transformer were going to fail. So then after investigation, when they opened the core, they found that these things are happening. But what is the culprit behind it? That was the oil itself. So such, maybe it may be manufacturing defect sometime, but supporting other things also can affect on our design. Then we have added some passivator into that oil and we have used, and from that there is no failure of the such converter transformers. So these may minute defects may remain in our design. So for that, such testings used. So here another impulse testing where you will find out exactly detect and locate the exact fault where there is in the particularly transformer. So there are certain methods like general observations, then voltage oscillogram method. On voltage oscillogram, you will get the graph of that. As per that only, you will find out exactly with the that magnitude only, you will find out where is the exactly problem. Then neutral current method is also there, and transfer surge current method. So these are some of the methods are there. In detail, you can go through these methods. They are easily available on the net. Next one is testing of isolators and circuit breakers. These are also important equipments after transformer. If you see, the cost of a circuit breaker is still more. So we have to again ensure its operation. It may happen that we have observed that many times breaker gets failed. Means even there is a blasting of these breakers. We have observed this during the fault. If that fault gets cleared, so these breaker poles get damaged and there is a blasting of these breakers. And sometimes it may happen also auxiliary equipments also, sometimes CT get burst or PT gets burst. Because of that insulation, that is a disc, whatever that gets thrown, that damage the porcelain insulator of the breaker also. So any auxiliary or any supporting equipment can affect our main equipments also. So we have to ensure the this proper working of each and every equipment. Again, we have isolators. In isolators, continuous that current flows, and these are actually mechanical switches, and these mechanical switches that also we have to actually ensure its operation, because of during the maintenance we have to open the breaker, open the isolator, and we have to perform the operation, maintenance of the equipments. So for that we have to ensure the testing of the isolators and circuit breakers. If you see, for the especially for the isolators and circuit breakers, so there are some dielectric test. So the in dielectric test, we check the insulation of the especially for these breakers and isolators also. Even they isolator, they check by fitting on the insulator. They actually in the factory they fit those isolator, that is a blade, jaws, and all these part they fix on the insulator, and then they test that for the different test. So over voltage test they carried out like power frequency, lightning, and switching impulse voltages. So especially for this, for the protection from the power frequency and lightning and switching impulses, so the dielectric tests are carried out. Then another is impulse test. Impulse means that still you apply that voltage or on the, especially on that breaker or especially on that isolators, and certain switching surge tests are also carried out by using the switching over voltages. Then temperature and mechanical tests, that tube tests, that also done especially for the to test the insulations of the circuit breakers and isolators. Then we have, for the isolators and circuit breakers, we have short circuit test. Short circuit test means actually they create the fault. Means practically actually they create the fault and they test the performance of that equipment. And generally at a substation, what happened, there is a breakdown of any line. So if that line falls on ground, it will act as a treated as a fault, and then breaker operates. So practically they test this at factory level also. They short the, they apply the particular voltage, they, and they short that specially, and then they see the results, whether it is successfully operating, which parameters, on which parameters, how is the timing of operation, in how much time that breaker open, how much time is the closing of that breaker contacts. So everything is tested. So short circuit tests, there are direct test using short circuit generator as a as the source, using the power utility system as the source. Means they are checking that, like you are creating fault from the generation side. Suppose from fault is from the generation side, means they are using the generator like a source to check the short circuit from the generation side. From utility side, again there is another method to, if suppose fault is from the utility side, again how will be the performance of the equipment, whether it is on generation side or from utility side. Still those tests are also actually taken. Again, certain tests are there, that is synthetic test on circuit breaker and isolators, like direct testing in the networks or in the field. So that those tests actually we carried out in the field, or we can say especially network. So generally where the procedure for this is, it is a limited energy consumption when electrical energy is diverted to other source of the network which is not connected to the circuit under test. Suppose there is a redundancy available in the network. I have two sources, means suppose any city is having two sources. So during testing, one source I can kept off, another source, through other source I can supply the power to that city. So in such condition, we can take this test directly on the, especially on the site or field. In that case, what we do, we actually open the line side isolator, means we kept the circuit open from the line, so that we can test over all the equipment in that bay itself. Then direct testing in short circuit test laboratories, where again in the direct short circuit facility, if it is there, so by short circuiting, again they test these test by dielectric testing, sorry, direct testing in short circuit laboratories. So these are the different types of tests available. Again, if you see for the circuit breakers and isolators, then synthetic testing of circuit breakers, that is a special, these are the some special methods. Even some videos also you can see for these testings. You will get some videos also how actually practically the people are testing these equipments. Then we have composite testing and unit testing. Composite testing means one number of lot you take and you test. Unit testing means single unit you choose from among the that slot and you just test. Many times it is not possible to test all the equipments. Suppose you have produced thousands of insulator disc. So how much you will be test? How many numbers you are going to test? You have to take the sample from that, or you have to take the batch of from that, and then you have to perform the testing on that. Again, for the circuit breaker, that is a, we know that open and closing cycles of the, that is the duty cycle of the circuit breaker. That is most important. How much, within how much time your circuit breaker should get open, and how much time it should take to reclose. So that cycle should be it tested. So that they have tested with different loadings of a rated symmetrical breaking capacity. Symmetrical means they create symmetrical faults on the especially RYB phases, and with the 10%, 30% means percentage wise they are going to test. So in different condition, they are testing all these breakers for their duty cycle, checking of the duty cycle. Then asymmetrical tests are also there. Suppose there is a single phase fault or double line to ground fault, like this means there is an imbalance. So that is a unsymmetrical testing is also carried out for the circuit breakers and isolators. Then we are having a surge diverters, which are known as lightning arresters also. Generally, lightning arresters we provide at the starting of line or any substation at the starting, or HV and LV side of the transformer. So these lightning arresters are used, and these are most important equipment because the first equipment which will sustain this lightning stroke, that is a lightning arrest. It is the first equipment in the switcher. So that's why these must be tested at their own level. So testing of surge diverters. So there is a power frequency spark over voltage. This is a routine test where it is conducted using a series resistance to limit the current in case of spark over currents. Means this is the just arrangement. They connect resistance in series, and again they check for the 1.5 times apply the rated voltage. Suppose this is a 420 kV rated lightning arrestor, then they applied 1.5 times of that for 5 successive applications. Even they check for the number of times for the same voltage. So in this way, they go for the power frequency spark or test. Then 100% standard impulse spark over test. So that is also they are going to take on the this especially on the surge arresters. We have again residual voltage test. Some formula is given here: V1, V2, V1 by V2 is equal to VR1 by VR2, where there is a rating of a complete unit, V2 is a rating of prorated unit tested, VR1 is the residual voltage of the complete unit, VR2 is the residual voltage of the complete unit. So here in this test, these surge arresters are tested with the voltage of 3 to 12 kV only. Means up to 12 kV they apply the voltage across the surge arresters, and they check this equivalence between these parameters. Means magnitudes of applied voltage and across what we get. So they check the uh, across the surge arresters. So when we can say that there is a successful test of the lightning arrestor, when there is a power frequency spark over voltage before and after the test does not differ by more than 10%. Means before carrying out the test, whatever voltage is there, and after carrying out the test, so that should not be differ more than 10%. The voltage and current waveforms of the diverter do not differ in two applications. Means whenever you apply these different different application, so there should be same performance by the that surge arresters. If there is a non-linear resistance element, do not show any puncture or flash over. So that also non-linear resistance is actually inside that diverter, so that element also should be checked for the puncture or flash over. Then again, some tests are there: long duration impulse test. Here duration of the impulse is more. Then operating duty cycle test, that whatever it take the impulse, within how much time it grounded that impulse. So that is also most important. If will sustain for more time, that for that continuous impulse, what will happen, that lightning arrestor itself burst, because it cannot sustain for the more time. Just impulse comes, and at the same time that should get grounded. Otherwise, after a certain period, if it is not grounded, if that lightning arrestor is not grounded properly, that impulse itself damage your this surge arrestor or diverter. It cannot sustain for the more duration, because impulse voltage, we know that it's thousands of kVs. It is so much, too much voltage whenever any lightning stroke comes. So that cannot be sustained. So for that, its duty cycle is most important. Again, mechanical tests like porosity test, temperature cycle test, pressure relief test. So these are some of the tests to check its insulation level. Then we have capacitor banks. Generally, capacitor banks are used at distribution side, especially for the power factor improvement and reactive power compensation. And there should be testing of these capacitors also. So for that, some methods are used, like there is a high voltage impulse withstand test to check the that is a what will be the effect of impulse, especially if it is comes came on this especially capacitor bank. Then there are leads of capacitor bank where you actually connect the conductor. So those leads, that is a bushing of that also should be get tested. Your capacitor is healthy, but the terminal is weak, still there is a failure of the capacitor. Then thermal stability limits means temperature. Generally, oil filled capacitors are used, or nowadays some paper means they are using dry type capacitors also. But still, thermal stability limit is most important, or how much temperature it can sustain. Radio influence voltage, voltage decay test, short circuit discharge test. So all these tests we have to carried out on the especially capacitor bank. Now testing of the power cables. Generally we use at even at 22 kV level, where there is a issue of especially right of way, when it is not possible to place any overhead line. So then we go for the cables. But generally there is a limitation with the cables, 30 to 40 kilometer only you can use the cable. But for advantage with the cable, there is a less fault, because if it is overhead, there is a definitely surrounding will impact on the fault level. But if it is undergrounded, there are less chances of the fault. So generally up to 30 to 40 kilometer, we prefer the power cable. There are variety of cables in the market. So the for these power cables, there are certain tests, like there are mechanical tests like bending test, dripping, drainage test, and fire resistance and corrosion test. Means to check its mechanical strength. We know that on the cable conductor inside, and there are so many layers of protection is given. There are shields and so many insulations are provided on that cable. So everything gets checked. If suppose there is a issue with any layer of that bindings, so there may issue in future. So for that, bending, dripping, drainage, fire resistance. Now in market there are some cables which cannot burn even with the fire also. Means fire retardant. Actually, their coating is fire retardant. So that also we have to test whether it is getting fired or not. So that fire resistance, corrosion test. Inside the cable, we know that there is some metallic uh, portion is there. Metallic sheaths are there. So those metallic sheath should not get corroded. If that gets corroded, that will actually uh, will damage the insulation of the cable. and it the means the cable will weak on that point, and it may puncture from that point also. So for that, all mechanical strength of the cable you have to check. Thermal duty, how much temperature it is producing whenever you are loading to 100% or some overload is there, how much temperature that cable is producing, that you have to test. Power frequency withstand voltage test, impulse withstand voltage test, impulses, that also we have to check. Sudden, all of a sudden, suppose over voltage comes, what will happen? Suppose impulse type of voltage gets applied, so what will be the strength of that insulation, that also will get checked. And life expectancy test, that is also there. You can calculate the for that from the that insulation level also. You can, there are testers, some testers are there, you can check the life of the life expectancy of that cable. So these are some of the testings which are carried out for the cables. The testing of bushings. Bushings are most important everywhere. If you see whether it is your any device, any equipment, so that get connected through the bushings. So that bushing should get tested at the factory level itself. So these are some of the testings of the bushings, like power frequency test. So under this power frequency, there is a power factor, voltage test, internal and partial discharge test, monetary withstand test and power frequency, 1 minute withstand test at power frequency, visibility discharge test at power frequency. So these are some of the tests are carried out on the bushings. Again, full wave voltage withstand test. So we, there is a, whatever voltage we apply through the that equipment apparatus, so there is a arrangement of apply the voltage in different patterns, like full wave or choked wave, like this. So in this way, if we apply full wave or choked wave voltages across these bushings, then you can check the its insulation. There might be the chances of some there is some voids remain whenever you construct any particularly insulator. So some gaps or voids remain inside that, and that may lead to the some leakages through that. So for this, during this testing, so this gate we check, this can be checked. Then thermal tests of the bushings, how much temperature it can sustain, so that also can be tested. So here we have completed today's session, and now before moving towards the question answer session, just I have one small information for you. As on this platform, we have started engineering student forum and all India Institute Industry Forum for the, this is for professional and this is for students. So you can join this and you can take the opportunity to get all the updates from the industries as well as from the institutions, like different webinars and different job updates from institution and industries. There are so many advantage if you going to join this. There is a guidance on your, especially for your projects, dissertations, seminars, thesis. You will get the guidance, even data we can provide. So this is a joint platform. We are coming from all our industries, especially from many institutions like NITs, IITs, CPRI, NPTI, many transcos, discoms, many members. There are more than 120 members are professionals from institutions and industry across India. And from these engineering students are at near about 300 to 400 students. There are two groups for this forum. So there are students are connected. So if you wish to join this forum, you are always welcome. This is my contact number. It is on WhatsApp, and this is email ID also. You can just send me WhatsApp message if you wish to join. So you can join this and take the benefit of whatever the facilities are available here. So I am thankful for this giving me opportunity for this session. Now the session is open for the question answer. If anyone has query, just you can please ask the queries. Hello, madam.
Yes, sir.
Am I audible, madam?
Yes, yes, sir.
Yeah, yeah. If someone has query, they can ask, or also you can write me also regarding this on my email ID, and this WhatsApp number is given.
Yes,
So
yes, definitely, sir.
yes,
So,
Sir, what is the difference between lightning arrestor and surge absorber?
generally, just these are the only we can say that these are the terms we used. Uh, Generally, both are same if you see like that. Just what why we called it as arrestor or absorber. Actually, it first take or catch means it create the least impedance path for the lightning stroke. So that's why it arrest or absorb. It create the least impedance path from all equipments. So otherwise there is no such difference in between that. Otherwise names are only difference. Both same things are same. Any other queries?
sir, are you following such kind of test at your end?
Actually, see here, no, we don't have such high voltage testing lab. Especially, these are the tests which are actually carried out where there is a high voltage lab. So generally, at our site, we take the field test, and during energization, if we have completed factory test and then some of the field test, then we actually energize the system, and even there is a proper procedure we have to follow. We have to take the permission from the electrical inspector of the respective district. We have to apply to the electrical inspector. He will come. If I want to energize a new line, new transformer, new equipment, then actually I have to apply. They will come to the our station. They will inspect all the things. They will check the results of the test, and then they will give the permission to charge the equipment. So we don't have such facility, but some possible tests that can be carried out, that we test at the here it in substation also.
Okay. Sir, actually, we have a very good HV lab and we want to go it for NABL accreditation. Are you
Okay.
aware of that NABL accreditation, sir?
Yeah, yeah, yeah. Yes, madam.
So, sir, is there any duration that is required, sir? Because our lab has been established in 1984, and
Okay.
almost all the equipment or apparatus that we are using are very old. We
Yeah.
have 150 kV transformer, we have 75 kV transformer also, and
Okay.
we have 150 kV generator set also.
Okay, madam.
So actually, we are trying to do the NABL accreditation for few equipments, not going for the complete lab because it's
Okay.
taking too much maintenance and the costing.
Okay.
So, is there any criteria, sir? The life of that equipment it should be at least 5 years or less than that.
Actually, madam, we have to go through the thorough proposal of there, because time to time these conditions check. Generally, if you have old equipments, generally there is a certain life of equipments. So whenever you go for the testing purpose, so after a certain period, the life of those testing equipments also gets reduced. Also the accuracy of those equipments. So it is my advice to first have a testing of those, means really these equipments are means they are in good condition, their calibration, that all things you have to first check. And also at the same time you should go through their online procedure, what actually you have to follow. And I can also later on, if you contact, I will also go through it, and I will also support you to make it practically possible. Because if you make this lab live, so your institution can earn from this lab also, because small industries not go for the that at more, that is a, we can say, like a VJTI and all those things. They, why they will bring their equipment to test in VJTI Mumbai lab? If suppose the vendor is from the our especially Nagpur side, so what he will do, he will go the lab which is near to him. Especially college even can earn from this also by taking this contract. Why even VJTI is actually testing all the most many industry equipments in the lab. So this is the possibility. Please give me some details about whatever details you have. I will again go through it, and I will contact with the experts. Definitely, I can help in this regard. It will be very good thing for your institution also if you set up it properly. Actually,
Yes, yes, definitely, sir. I will contact you. And
yes.
actually, our senior professor, Dr. T.G. Arora, is was handling this lab previously,
Okay.
and our lab is really very good in Vidarbha region. No private colleges is having such HV lab. So we
Yes,
are
ma'am.
planning to do NABL accreditation for that. So I will definitely contact you, sir, for details.
Sure, madam. I can help in this regard, because I have now taken the accreditation for this ISO certification. So I know the some of the procedures. Just I have to go through the NABL also. I can check it. No issue.
Okay, thank you very much, sir. Thank you
Thank you,
very
ma'am.
much for your kind cooperation as well as this guest lecture, sir. We hope your cooperation in future also.
Yes, ma'am. So I am also thankful to you and your college also, and all the participants for active participation in the today's topic. Actually, today's topic is very different, and generally we have no much more interest in the IS and ICs, but as much as I tried to make it easier, so that you will get the feel of this. So once again, I am thankful to all of you. So, madam, can I leave the session?
Yes, yes, sir. Thank you very much, sir. So I
Okay.
request all the participants to leave.
Thank you, madam.